All attendees are in listen-only mode.
Good morning, everyone. I'm Kendall Trump with Grain Journal Magazine in Decatur, Illinois. Welcome to 5 Common Bottlenecks in Grain Facilities. This is the 8th in a series of webinars to be presented by GEAPS and Grain Journal Magazine in 2018. Generally, our society has grown to continually demand results that are bigger, better, and produced faster, and the grain material handling industry is no exception. Today's webinar will share 5 facility pinch points in the order of operations that could impact safety, production, and dollars. Our presenters today will discuss finding the balance of labor and automation, alleviating site traffic issues, hiccups in grain receiving and material handling, effective use of outside storage, and maximizing rail receiving and loadout for shuttle trains. We do hope to see you at GEAPS Exchange 2019, which will be held March 9th through 12th, 2019 in New Orleans, Louisiana. Today's webinar is sponsored by M&M Specialty Services. M&M specializes in protecting your people and products with the best in quality and affordability in personal protection products, grain protectants, fumigants, and services. They are based in Leavenworth, Kansas. Our presenters today are Doug Rohkohl and Pat Kanan of VAA LLC. If one word could describe Doug, it is detailed. He has channeled his natural detailed demeanor into general arrangement design and structural drafting for grain elevators, feed mills, and other agricultural bulk material handling facilities. A graduate of Dakota County Technical College in Rosemount, Minnesota, and with 14 years of experience, Doug's understanding of slip-form construction makes him a valuable mentor for employees and resource for clients. His role encompasses service from the early stage of project planning to project closeout. He prepares construction documents, specifications, and oversees plan quality reviews. And since joining the firm in 2007, Pat Kanan has taken a lead role at VAA in rail design and navigating the railroad submittal processes. A University of Minnesota Twin Cities alum with a BS in civil engineering, he is responsible for designing rail for shuttle trains, grading plans, storm, weather, and utilities, generating site layouts, and coordinating permitting with regulatory agencies for new and existing bulk commodity handling facilities. Over his 14-year career, Pat has made efforts to meet with clients early in the design phase to better understand site needs and business objectives. He recognizes the value these early encounters have on a project, which is reflected in the plans he delivers. Pat is a member of several rail-related organizations, including ARDA, AREMA, and NAMRC. Please feel free to ask questions today by typing them into the questions box at the right-hand side of your screen at any time during today's webinar. We will be answering your questions during a Q&A session following our presentation. We do have one polling question for you today. How many people are viewing at your facility? Thank you for your participation. As a note, today's webinar is being recorded and it will be posted to our website, grainnet.com, within 24 hours. All registrants will also receive an email containing a link to our recording and our presentation slides. At this time, Doug and Pat, can you please do a voice check?
Hello, Kendall.
Hi, we can hear you perfectly. Now, can you please show us your screen? There we are.
Showing up?
Yep. Ladies and gentlemen, here are Doug Rohkohl and Pat Kanan.
Thank you. So in our presentation today, we're going to talk about a number of things. The first one is ways to help keep traffic flowing through your site and minimize backups, ways to get trucks unloaded faster at your facility, talk about how automation can help run the facility with less labor, limit product damage and labor in filling and reclaiming outside storage, and what are some options to make loading trains easier and faster. Pat is going to now talk about alleviating site traffic issues.
All right, thanks, Doug. There's going to be three main subjects that we're going to go over today. Routing, and then scale and probe locations. The first one we're going to discuss is the staging area. So staging area being defined as the area between the entrance to the facility and all the way up to the probe location. Typically what we see for these facilities is you get your peak harvest time. You're getting anywhere from 250 to 500 trucks per day, and it requires a lot of stacking space on site. What we typically like to do is add 3, 4, 5 lanes with future capacity, and in this case it would be on the north side of the road here to add in future stacking area if needed to prevent trucks from stacking up out on the local road there. And also to prevent, since most of these facilities are adjacent to track, to prevent any vehicles from stopping on the track or getting hinged up on there. We also like to keep as much length as we can too from the beginning of end there. The probe is going to be the most time-consuming aspect of the trucks driving. So locating the probe, kind of centering it between all the truck lanes will help allow you to probe from the north and the south side of the probe, limiting the time that the probe sample takes, getting it to the office and into the lab. From there, we go to the inbound scale. The inbound scale is usually located about 3 to 4 trucks. In this case, it would be to the west of the probe location. This allows the trucks to straighten out. Typically, we're seeing more above grade scales, so they'll need to ramp up. It'll take a minimum of 30 feet to ramp up to those scales, both on the approach and exit side of the scale. So allowing enough adequate room makes those truck movements a lot easier. If a truck gets rejected, they're not going to be bottlenecked in there because we didn't provide adequate space for that truck to get around the scale. So really alleviating those site issues, getting adequate space, planning for it, it's critical to that initial success of getting into that inbound scale, getting that sample. From there, the scale into the receiving building, we want to still provide adequate staging area. Doug will get a little more into detail on this, on how many lanes we have, but there'll be multiple lanes typically, and we want to provide enough so they can separate out into what commodity it is, and they're ready to go. There's no downtime in between the scale and receiving. There as minimal as possible. And then we move through the facility here, trying to get the trucks in. Again, time is of the essence here. The slower this process is, the more trucks that back up, and the more staging room that's required. Finally, we have the outbound scale location. Again, we want to get those trucks running in a linear fashion over the scale so they can get on and off the scale. Ideally, this scale is still visible from the office location. All scales are in the probe. Most owners like to have a visual, whether they're using cameras or not. They still like to be visually out there in case there's any issues. From there, from an economic standpoint, you want to minimize the amount of road onto the adjoining exit. One thing you'll notice here, in an ideal situation, this was a greenfield site. Not every site that we're going to deal with is going to be that, but we have the trucks moving in a counterclockwise fashion. What that does is allow the truck to be on the right-hand side of the road. This reduces any cross-traffic with any non-truck traffic on site, and it provides a safer facility there, and also alleviates any bottlenecks with congestion of getting vehicles in and out from an employee standpoint. Typically, we like to design them as a one-way facility as well. this also alleviates any crossing and congestion and any confusion on site. It's easy to put up signs on where the trucks can go and inbound non-truck traffic as well. One of the bottlenecks seen on typical projects is it comes from a scheduling and timing standpoint. That's one of the biggest concerns we have on site is how can we get all this done within the time frame that we need to. The DOT will come in and see all these trucks, and they'll be concerned about those backing up there. If you can show you have adequate space on site and run through a timing program, they're usually pretty conducive to not putting in turn lanes or deceleration or acceleration lanes, depending on the specific site. So with that, I will turn it back over to Doug here and talk about receiving and material handling hiccups.
Okay, so at the receiving pits, there's generally a few things that you can do to really help speed up how fast you can get trucks through the facility. The biggest one is the size of your receiving pit. Now, when I say receiving pit, I'm talking specifically about both the receiving grate and the hopper below it. So to optimize getting trucks in as fast as possible, you want to have a receiving grate such that if a truck pulls over it, it can open all of its discharges at the same time and just let the material flow out into the grate. So now this doesn't just include the length of it, but you also want to make it wide enough so that you're not constantly getting material flowing off the side of the grate. In addition to help with this, you want to have a large hopper underneath that grate. What that does is allows you to open up the truck completely and eliminate having any sort of impediment to the material flowing out. Now, when you're looking at exactly how big the grate and the hopper needs to be, it's going to vary somewhat on a case-by-case basis, and it's also going to have to be sized in coordination with the reclaim equipment. However, a good rule of thumb is for the hopper to be able to take one truck of material. So you've got your hopper and your grate there. The next thing is have an employee there to open the truck hatches at the bottom, right? So a trucker pulls in, has to get out of his cab, walk down, open up the hoppers, stands there. When it's done, close the hoppers, and get in his truck. Well, that time for the trucker getting out and back in is additional time that you're using up in the cycle. Another issue that we sometimes see is truckers don't always want to open their gates all the way. Sometimes they're open them just partially because they don't want to have the grain, they're afraid of having the grain back up and flow over the sides of the grate, which gets back to sizing the grate properly. So it eliminates some issues like that. And also, truckers do tend to talk with other truckers and employees. Keep them in their trucks helps limit that as well, keeps distractions from happening. So now you've got the actual pit there, resizing the receiving equipment. Now, when you're sizing the equipment, looking at how fast it's unloading, and that is one thing that you want to analyze for cost of what you're willing to pay for and things of that nature. The bigger issue to address, though, is bottlenecks. And when I say that, I mean if you have a 25,000 bushel per hour receiving conveyor and a 20,000 bushel an hour leg, you've got a bottleneck there. So making sure that all of your equipment is sized to work with each other so you don't have one weak point or specific bottleneck in the system. This can be equipment speeds, it can be spouting sizes, all sorts of things like that. So just doing an appropriate analysis of the equipment to make sure that everything is going to be working at its peak efficiency. The last item I'm going to discuss here is consistent pits for varying commodities. So if you look at the photo there, this facility has 3 receiving pits. So ideally in this facility, if you're receiving, say, 3 commodities, each one of those pits would be for a different commodity. Because when you're receiving material, if you have a truck of corn that comes in and dumps, and then the next truck is for soybeans in the same pit, you have that time where the equipment has to all empty out and get to the bin it's going to, and then either the new equipment has to start up or the distributor needs to just change spouts and things like that. You've got that time in there where you're cleaning up the one commodity while waiting for the other, which can eat up a lot of time. So if available with multiple pits and things work out, it's best to try and keep consistent commodities at consistent pits. One thing that we have seen at some facilities that only have a single pit, which is the case with a lot of facilities out there, we have seen them make efforts to try and schedule times where they're receiving certain equipment. So for example, 8 in the morning till noon, we're receiving corn, noon till 4 in the afternoon, we're receiving soybeans, and then 4 till 10 at night, we're receiving corn again. In an ideal world, that works great. We fully realize that that's not always implementable at a facility and would work with varying success, but it is something that we have seen people attempt with some results. So the next item we're going to talk about is automation, specifically finding the balance between labor and automation. Labor is hard to come by, and when you do find it, it's hard to retain it. This is the case with not just the grain industry, but most industries in the country right now. So how can automation help you? Well, automation can basically do the work that you may have employees do, and you can do this at various levels. So we're going to start out with a partially automated system. This will generally involve installing a PLC or a computer to run your facility. You'll have a central computer in an office. Sometimes you'll have various terminals located around the facility where you can start and stop equipment and run it. This PLC is typically hooked up to safety devices so that if there's an error, it'll shut down all the appropriate equipment. Not just the machine that had damage to or had an error in it get damaged, but any other equipment going to it or from it, help prevent that from getting damaged as well. Another thing is a bin inventory system. So not just necessarily high-level indicators, but continuous level indicators to help you know. So it can tell you if a bin, help you tell you if a bin is full or if a bin is almost full. Like there's not really enough room to put a whole truck in there, but it's not quite set. The beauty of these systems is it can really help you out in the paperwork of tying it into your accounting software. So if you've got records in there of this truck brought in, this quality of material that you're entering in, it weighed this much, and dumping it, it'll help you keep track of what you're paying your truckers. It'll also help you keep track of your inventory. So when you have enough to ship, if somebody calls up and wants to know, hey, I'm looking for 20,000 bushels of corn, do you have that? It can make a lot of that stuff real easy to access. So now, this is kind of a simple version of how a PLC system would typically work. So let's say we've got a receiving pit with a truck and we want to send it to the bin on the end there. So what you'll do is you'll click on those two items, truck to bin, and the system will go through and start up the equipment in the appropriate order. So the first thing it'll do is it'll check, make sure the fans aren't running, and that's so when you are dump filling the bin, it's not throwing dust everywhere. And then it'll slowly start up the equipment. I guess slowly isn't the word. It'll start up the equipment in a fashion generally from the destination to the origin. Getting all the positions set, starting it up, checking the right gates, starting up the dust system or the dust containment system associated with that equipment. And then once that's up, setting up the equipment, and once everything is up and running, it'll start up the last piece of equipment, which is the pit, start getting the material moving forward. This also works in reverse. When the system's done, what it'll do is if you say, all right, the truck's unloaded and hit it, you can have a delay built in there to make sure that the equipment is cleaned out before it shuts down. So it'll shut down the drag once it assumes that's empty, and then following that delay, the associated dust collection equipment, and then the distribution equipment up top until you've got your material in the bin. So now going a step up from that is a more fully automated system. This typically involves using an RFID system on your facility. An RFID system is where you have a tag in the truck that there's various sensors that reads, so wherever the truck is on the site and they have readers, it knows where that truck is. This helps out because it helps check trucks in and limits the number of employees needed to talk with truck drivers, direct truck drivers, and things like that. Keeps the truckers in their truck, like we talked about before. And as I'll show you in a little bit, it helps mitigate putting the wrong product in the wrong bin. So we go back to our site here. Trucker comes into the site and pulls up to the probe. There's an RFID reader at the probe. The probe will go and probe the truck. Now, there are actual automated probes that are starting to be out there that don't require somebody to run them, but most facilities nowadays are still going to be using a probe that somebody's controlling. But what it does is the RFID reader says, all right, this truck is currently being probed. When the sample comes in, it tags the sample. If you've got automated sampling equipment, it automatically logs the results of that to this truck. Otherwise, whoever's sampling it can plug that information into the computer right there. So all that information is logged into the computer with the truck. The truck will go ahead, get on the inbound scale. It'll weigh it. That'll get entered into the computer system with the truck. Now, sometimes there'll be a display board here, or if you need to have a little more time for the sampling and grading between the probe and the inbound scale, and before it's ready to move on, you can have another staging area here with another RFID reader in display. And what this will do is once everything's been graded, it'll tell the trucker which pit to go to. So the trucker will then move forward to whichever pit they've been assigned. And there'll be an RFID reader at the pit. What this does is it tells the system to make, hey, the truck's at the right pit, or more importantly, it'll tell them, hey, the truck's at the wrong pit, so that you can have several actions, like maybe the equipment will stop, or you'll have some alarms and sirens go off, or notification go off, hey, you're at the wrong pit. So what that does is that'll help you keep from accidentally putting corn in your soybean bin or something like that. So now once the truck's done here, it moves to the outbound scale. We have another RFID reader. It takes the weight of what the empty truck is. It looks at what the inbound weight is, what the grade of the grain that was brought in, how much you guys are paying for that, and it'll print them a receipt with all that information on it right at the printer there. They can grab that, and then they can leave the site. So what this does is this really limits how many people you need in order to get the trucks through the facility. So now moving on, we got our fourth item here, which is effective use of outside storage. Now when we're talking outside storage, we're talking specifically about ground piles versus bunkers versus buildings. So now all of these items serve a great bottleneck in harvest time, meaning, hey, you need a quick place to put a whole bunch of grain. You don't necessarily need to store it for long periods of time, but you just need to put a bunch of grain somewhere quick and inexpensively. And all of these work good for that purpose. Ground piles are labor intensive, and they produce quite a bit of, well, they produce high risk of damaged product. They're typically just kind of dumping it on the ground somewhere at your facility. Sometimes you'll have a prepared pad. Sometimes you just have an open space where you're like, hey, I can put some grain there. You're typically filling it with some portable conveying system that you have to have people moving around, not to mention that system is generally not as fast as your main receiving system at the facility, which is going to slow things down, take more time. You're generally not going to have aeration in this. It may or may not be tarp. If you are tarping it, you have all that time that you need to take and tarp the pile. And then when you're reclaiming it, you'll generally have either a front-end loader or some sort of pile reclaim equipment that's putting the material in a truck and taking that back to the main receiving pit. So even though it's a great inexpensive way to get a bunch of grain down, it's pretty labor intensive to do so. A step up from this, which cuts down on the amount of labor you'll have, is a bunker system. This is still time consuming to tarp and reclaim, but it's a lot less labor intensive because it's generally tied to the main receiving system at the facility. So the trucks are just going along the regular path at the main receiving pits. Your employees are just out at the main receiving pits doing their stuff. You don't have to have anybody special out there moving the equipment or having a slower system or anything like that. These, are generally on hard surfaces like asphalt, which helps when reclaiming it, as you're going to get less product damage in that, because when you're getting it back, you're not going to be leaving an extra layer on the bottom, or you're going to be scooping up gravel in that width, trying to skim that bottom layer of the pile off. These a lot of times will have aeration with a center aeration pile or aeration tubes put in. However, if you have the aeration tubes put in the floor, there's labor involved with setting those up. However, that's generally before harvest starts, so it helps you out a little bit during the rush. And then tarping systems. There's automated tarping systems, which the tarp will raise and cover the pile as it goes, but you still have to get it set up and hook it up around the pile. Otherwise, if you aren't using an automated one, you still have to go and tarp the pile. And as with reclaim, you start to see automated reclaim systems with conveyor systems extending into the pile in this. And we'll talk about those a little more in a minute here. Flat storage building. So flat storage building still has the time to reclaim, but you lose the tarping and a lot of those issues associated with it. And it also cuts down on the product degradation when reclaiming it. Typically, these will have concrete floors. They'll be tied into the main facility receiving system. A lot of times, these will have aeration systems already cast into the floor, so you don't have to worry about setting up the tubes or anything like that. And then with the concrete sidewalls and the roof structure, you've got an enclosed shell that is going to keep the product protected from the elements, and there's not like labor of having to put the tarp on and off and stuff like that. And lastly, with these buildings, you generally see reclaim systems via tunnels and that in the bottom of these, which will help reclaim a portion of the building before you have to go in there with like a front end loader to move the stuff around. So now with all these systems, reclaiming it is generally the most time-consuming, labor-intensive part of the item. So if you put in a reclaim system, being a conveyor that runs underneath the pile, what this can do is it can help you eliminate having to have trucks driving between the storage area and the main receiving system. Now, this can be done to various extents, whether it be just having a single grate just inside the wall that you can move all the material to, or if you have the conveyor extend to the center tower, like the picture on the right there, or even extending it all the way through, which is going to allow you to gravity reclaim as much product as possible before you have to go in there and start moving the product around. Now, this can be done with either just a shallow trench that you just embed the conveyor in, kind of like the one on the right and the left there, or it can be done with a full-size tunnel in case the conveyor breaks and you are worried about getting down there to fix it or something like that. Now, if you are reclaiming with a truck and you don't have the automated system in there, there's a few things you can do to help you out as well. So we've got the site here with the ground piles inside the loop track. So what you're doing is, if you're reclaiming this, you've got a pile reclaimer or a front end loader that you're using to fill trucks. The trucks are looping around, going over to the main receiving pit, dumping the material, coming back, getting filled up, and continuing so. Now, another thing you can do is you can put a pit on the back side, basically where your rail reclaim is, or on the inside of the shuttle. What this will do is this will cut down on the distance that the trucks need to drive and the navigating situation to get to the pit, and just makes it a little easier. The downside of this is you're not necessarily going to put as big of a pit back here as you do at your receiving building. You can, but it'll probably be a little bit slower because you only got the one pit in that. However, if you happen to have a shuttle train there that you're loading, or parked on your tracks waiting for the BN or whoever to come and pick it up, what it allows you to do is keep reclaiming that ground pile while you're loading the train or while the train is blocking access to your facility, which means that it's not shutting down a process that you could be doing. And in fact, there's a number of facilities that when they're loading trains, they'll be reclaiming the ground pile and sending it straight to the train. All right, so I'm going to pass it back to Pat now, who's going to talk about making rail work for you.
All right, thanks, Doug. All right. So we're going to look at a couple different types of facilities. The first one we're going to look at is going to be a loop track, and then the second one is going to be a track siting. Two different types of layouts with the end goal of getting a 24-hour turnaround to meet the mainline requirements for getting a unit train in and out of that facility. So the bottleneck here is going to be speed and efficiency of the rail. They like that 120 car string so they can come in, pick up a single product, and move out. It doesn't congest their main line. So they have incentives for owners, reduced rates to move that product at a quick rate. So the first site being a loop track, going back to the facility that we've been looking at today, takes a large piece of land. It's about 140 to 160 acres, about a quarter section of land. Not all pieces of land and rail run in perfect rectangular location, so it really is kind of site specific. But what you need in this piece of land, when selecting a piece of land, is make sure you got about 2,000 feet in width at a minimum there. That allows for the proper curves on site and for enough grading and ditching to not have to impede on existing right-of-ways of roads and rail. So that loop track that you see there, typically they're about 8,100 feet in clear length. And then you have additional track to get on the main line. You may need to purchase additional land if you need to have 2 entrances and exits to the facility. So real bottleneck with some of these facilities when planning them out is, did we purchase enough land? It's much harder to go back after you've worked out agreements with a property owner and say, hey, we need to get another 5 acres here. It's amazing how that additional 5 acres increases in value fast. So planning ahead, thinking about this, getting this approved through the main line can save a lot of money and time, and also help with efficiency on site. One of the main things with loop tracks is they're very efficient in the fact that everything's connected. You're not disconnecting any cars, and you can unload cars at a very quick rate. Once a facility is up and running and the staff is used to handling a unit train, it can typically take 8 to 10 hours. So getting it done in a single shift is kind of the goal. Not having to get additional staff out there is kind of a real benefit of a loop track. And typically you want to have these loop tracks flat. You want those cars not to be banging or bumping each time you're moving it over the loadout spout. That really helps. Now these sites are long. You're talking, maybe 4,000 feet in length and a couple thousand feet in width. It's not always a flat piece of ground that you're working with. So, we like to see, I consider flat 0 to 0.2%. 0.2% is 2 feet a drop in 1,000 feet. You can go up to 0.5%, but really there's a lot of push and pull in that type of situation. So getting some eyes on the ground out there, seeing the site really helps as part of that planning and eliminating some of those inefficiencies with a poorly planned site. One of the things we like to do is get that loadout spout so the cars are straight coming in there. So you like at least 100 feet before either a structure or the loadout point. That gets a grain car straight so that there's no additional movement of that car that's needed. And the guys moving the cars on site can do it efficiently and predictable. Another thing you want to take a look at is putting in a bad order track, just setting aside area for 5 or 6 cars just to store there, cars that the gates don't shut or whatever issues that they have with them. Really helps to keep your facility moving when you can deal with those cars at a later time. Moving on to the second type of facility is a ladder track. The ladder track takes a little bit more planning. Loop tracks are pretty straightforward. Ladder tracks can be just a typical sawvide track where you have, it's probably the most common layout that you see, or you can have a situation like the one shown here where you've got different products, different storage areas for a facility, and here's how you can move into expanding that into a unit train capable facility by adding additional ladder tracks along that are parallel to the main line. You can see here we indicate the red cars as full and the green cars as empty. This is called a sequence of operations. It tells the owner and the main line how these cars are moving around. Do we have enough clearance to move these cars to the facility? And we also, it's also good practice to put in some timing on here at what rate these are going to be unloaded, how much time does each movement take. It's going to take longer for a ladder track to move than a unit train because of the downtime you have with shuffling cars. Each ladder track has a string of cars that it can move. You know, in this particular case, this is about 10 cars here. With 120 cars, that's 12 different strings of cars you need. And if each time your downtime is 10 minutes to go grab another set of 12, that's 2 hours of time. So really laying the sequence out, having understanding, let the owners know, the operators, really ties everybody together so they're on the same page that this track is buildable, you have enough land to do this, and it meets the needs of the main line to get there within 24 hours. And finally, this last slide is showing how, in this particular case, that the main line would come in and pick up 2 strings of 60 cars and depart off to the east in this particular location. So this gets approved through the main line. They understand how it works, and it's really a cartoon, but it's very, takes something that's complicated and simplifies it very quickly. So that really helps get the approval process going, which can be probably the biggest issue with track projects is getting the main line to approve how this facility is going to operate, getting everyone to agree. There's a lot of entities within the main lines that have to approve these projects. It's not just the geometry of the site, but there's business units, scheduling of other rail in the area, and such. I'll pass it over to Doug now to talk about rail receiving and loadout.
Yeah, so with your systems here, it's important to look at a number of things for specifically loading out trains, receiving as well. But the first thing you want to look at is adequate bin storage for filling the trains. So is your facility large enough and the bins you're going to be pulling off of such that you can get all of the material into that train out of the bin or the storage thing by gravitating it? Or are you going to have to activate some sort of sweep or a floor aeration system or a canal system to empty the bin out while you're doing it? So when you're looking at that, you have to take that in consideration when sizing your equipment in the time that you need in order to get the train out. So ideally, you want to have a plan to get the bin so that you're gravitating all the material you need to get in a train out without having to rely on one of the systems that's going slower, or having a plan in place where as you're activating, say, like a bin sweeper, that on the first bin, you're emptying from a second bin at a slower rate. So now, same with the receiving system, looking at the various components you have and making sure that they're all sized to work appropriately with each other at the rate that you need. You know, having the conveyors and legs and all of that match up with the same speed. Now, what that speed is going to depend on a number of things, and this kind of gets down to sizing the bulk scale on that. So if you have a train that's on a shuttle track and you've determined that, or on a loop track, and you've determined that in order to load it in 10 hours, it needs to be 60,000 bushels an hour, that's fine, because if you're just pulling that train through, you shouldn't really have much for hiccups. However, if you need to load in the same time and you have a ladder track and you've got that 2 extra hours that Pat mentioned that's going to take you to load the train, then you're going to have to look at upsizing your system because you're going to have to load each individual car faster to hit the deadline. So now, specifically with the bulk scales, with the upper garner and lower garner sizes, one of the key things is if you have a loop track with the train, or even a shuttle track with the train, and you're going through and you're at one car, and then you need to stop the system briefly to get the spout to the next car, you don't want to have to stop all of the equipment. What you want to do is you want to look and make sure that you have your upper garner size such that the reclaim equipment can keep coming in while you have those couple of seconds where you're going from the one car to the next one, and you don't have to shut everything down. That can vary in size 2 rail cars is what a good rule of thumb for that, though it really takes more of a time study to know exactly what you need for sure. In general, with a ladder track, you're just going to have to shut the stuff down between streams. There's really not a way around it unless you have like 2 locomotives and you're pulling the one string out of the way and the other one can jet in there real quick. Then you just need a even bigger upper garner. Another thing that we've been seeing in a trend in the industry lately is actually having 2 lower garners on a scale that are sized for an entire rail car. So what this does is when you get a rail car up there, you already know how much material is in that one garner, and you can just fill the whole rail car while the other bin's getting filled. Once that was done, you move to the next rail car, you open up the other bin and dump down. This is obviously a little more elaborate and whatnot, but it's starting to become pretty popular in the industry. The last thing you do is you want to have a loading spout that's easy to operate. You don't want to have some complex thing where they got 2 joysticks and they're driving around and they need to, thread the needle. But you want to have it so it is somewhat flexible in case there is a little bit of a misalignment on a car or something like that, so you can adjust it to make up for those issues. Right. So now, one last thing we're going to talk about here is master planning, and this is more along the lines of getting a project started and eliminating the time that you're going to have at the beginning of a project to get it to completion. And Pat's going to talk about that.
All right, thanks, Doug. So some typical site issues that you run into. Most of the things that we've looked at today, we've done a lot of planning with aerial photos, laying out track, and then you come along to things like wetlands. These can be observed. You can look online. We'll have some mapping for that, just some site observation. What it really takes is a professional delineator to come out and verify these areas. The key component to this, though, the bottleneck is you'll have this facility, and it might take 12 to 18 months to build. And if you don't plan for investigating wetlands at the beginning of this project, this could end up being the last thing that prevents you from getting product to your site. So the best thing to do is go out, label the areas you think have wetlands, and get it delineated. And that wetland delineator will let you know, hey, this is going to be a 3 to 6 month process through the Corps of Engineers. Or if it's a higher value wetland, it might be 6 to 9 months. But that's very critical in getting that approved and getting all that in place, because you can't move any dirt in that area until that's approved. So being aware of that, these rails act as dams and they create wetlands alongside there. There's a lot more there than most people think from their first observation. So tackling this issue head on will alleviate that bottleneck in the construction process, and it's something that can be done relatively inexpensive and provides a ton of value. Land purchase for a track siting here too. So when you're looking at track siting, you're purchasing usually from multiple owners along there. And you can plan that out mostly from an aerial photo and some site observation. Then you follow up with actual design, with a survey and design drawings. But getting that rolling right away alleviates a lot of bottlenecks on site. Negotiations for land, cost, all those things take a lot of time. And you're not doing anything on that property until it's owned by that owner, or if there's an agreement in place prior to that. I would say that's probably one of the top issues with getting these projects rolling from a track standpoint, is getting that final document signed that it's legally owned by this new owner now. Typically, railroad right-of-way is 50 feet, sometimes it's 100, and to go beyond that, you usually need at least 25 feet of land on a ladder track. So if you're doing that over, say, 12,000 feet, that's going to come out to about 6 or 7 acres of land. And not everyone is willing to sell. So these are discussions you need to have ahead of time and work with your designer on that. Here, this is just follow up on a land purchase. You can see typically the 0 area is the center line of your proposed track, and how much real estate it takes to get in 2 rails, an access road, and then provide some grading. You can see over here we're at about 63 feet from the center line of that track, plus an additional 20 feet over to the main line. So it takes, this one's actually showing about 83 feet from the main line where we tie grade into. So planning ahead, assuming you're going to need that, it's a lot more land than most people think. Buying a little extra is definitely invaluable. It'll save money from retaining walls and such. The last item that comes up is the unknown, which is underground. Underground utilities, gas, electric, phone, fiber optic, water main, sanitary sewer. Those things are beneath the rail, and they usually have easements with them. Not all of them are labeled. But having conversations with the main line, with local utility companies, and letting them know what your plans are can really help alleviate delays during construction. Relocating a gas line, something that takes months, if not up to a year, to get approved through these facilities. So have those conversations up front. It'll alleviate a lot of stress during the construction period and unknown costs, getting those identified early on. So with that, that was our presentation. Doug, do you have any?
So yeah, thank you for listening. And is there any questions?
Thank you both for a great presentation today, gentlemen. This concludes the presentation portion of today's event. We will now begin our Q&A session. If you have not yet submitted your questions, please do so at this time. Okay, our first question for today is, what design impacts from rail do we need to know about that will determine the type of rail car mover that we use?
Yeah, there's a couple things that impact what type of rail car mover will need to be. You know, if you're looking at a loop track, you're going to need a locomotive. That comes down to the grade, and if you're pushing or pulling uphill, generally we like to have a flatter site, so you need less power. If you're looking at a ladder track, it's going to depend on the number of cars, which direction the empties and fulls are going, and the grade of the site. And then another factor would be the curve that the rail cars have to go through. So if it's a very tight curve, it's going to take more power to get through there. So it really depends on that specific site, but it can be a trackmobile if you're moving 10 cars. If you got to move 60 cars at a time, you're going to end up using a locomotive in that fashion. And if you're pushing fulls uphill, it's going to take a lot of power to get up there. So each one of those factors are given to a locomotive company, and then they'll size it appropriately based on that.
Thank you. Okay, our next question. Can you please discuss the cost difference between a ground pile, bunker, and building?
Sure. I can, to an extent. It's tough to give an actual dollar per bushel or anything to those things because it all depends on the region, what you're putting in for reclaim equipment and fill equipment and things of that nature. But I mean, in general, ground pile is going to be your cheapest. A bunker is going to be somewhere in the middle, and then flat storage is going to be the more expensive option. Though all of those will generally be less expensive than upright storage via still bins or slip form silos. Though there have been issues where we've been surprised and steel bins have come in relatively cheap. But I can't assign a specific dollar value to those, but that's kind of the order of cost, I guess. And as I said, it all depends on what accessories you want with it.
Certainly. Okay, our next question. Do you have any recommendations for a bin or silo cleanout system to load shuttle trains?
Yeah, so there's a couple of different types of systems. Depending on, and it all depends on the size of the silos or bins that you have. Concrete silos that are kind of smaller diameter and taller, you can put kind of sloped concrete hopper bottoms in, which will allow you to gravity pretty much everything out. There are flush floor aeration systems, or kind of like a canal style system, which allows for you to clean out the bins pretty easily, where you're using air to kind of blow all the material to the center or wherever the discharge of the bin is and empty it out faster. Those have been fairly popular at shuttle train facilities where they're trying to get the bin emptied quickly, though those two tend to be not absorbently expensive, but they are pricier. And then you've always got the bin sweep that you can use to clean out the bin, but that that's going to be slower. You're looking at about 10,000 bushels an hour for the maximum on that. The one trick with the previously mentioned canal system is that those generally don't work in steel bins. In order to get that to work in a steel bin, you have to build this concrete wall up like 10, 12 or so feet above the floor of the bin before you set the bin, in order to get that to work for all of the ducting and air and stuff like that. So, as I said, with shuttle trains, it's best to try and just do everything with gravity, and then once you've got this train loaded, just condense what you had in the bins into another bin to prepare for the next train.
Okay, thank you. Next, by loading train cars at a faster rate, does that increase damaged product?
That's a good question. So, in general, when you're moving material, if you're moving material in equipment faster, such as you just kind of crank up the speed on your leg or your conveyor, that will damage material faster. However, if you're saying going to put in a 60,000 bushel conveyor, but then you're looking at an 80,000 and wondering if the 80,000 is going to damage it more, generally not, because the damage comes in when the material is interfacing with components of the equipment. So if you have a larger piece of equipment, the amount of grain to surface contact ratio you have is actually less. So in theory, the larger piece of equipment you put in, the less damage you will be doing to the material, assuming you have all the stuff set up, hooked up right, the transitions are appropriate, and things of that nature.
Great. Okay, next, how many acres of land do you need for a loop track?
A loop track typically would be about a quarter section of land, about 160 acres. Now, not all sites are created equal. Some sites have a lot of wetlands, or they'll have topography on site where it's cost prohibitive to use that portion of land. So, you can go beyond that. I think it's really site specific, but that's kind of the base starting point. And you have to look at stream crossings or rivers, all those other factors on site really determine how much land you have. So there's not one set value that these sites sit on, but usually 140 would be the smallest you could probably go on a perfect site.
Okay, thank you. That is all the time that we have for questions today. Thank you for your participation. If your question was not answered, it will be sent forward to our presenters. Or you can feel free to contact our presenters using their contact information shown on the screen now. And that is all that we have for today. I want to thank our sponsor, M&M Specialty Services, for their support in bringing you today's webinar. And I also want to thank GEAPS and our presenters, Doug Rohkohl and Pat Joehnen from VAA LLC, for joining us today. As a reminder, this webinar has been recorded and it will be available for viewing on grainnet.com within 24 hours. All registrants will also receive an email containing a link to the webinar recording. Our next webinar will be on Wednesday, September 26th at 2 p.m. Central Time. We will be discussing facility design, maximizing efficiency and throughput, presented by Kurt Rosentrader, PhD, Associate Professor and Engineer at Iowa State University. I want to thank you all for attending, and I wish you all a great day.